Welcome back. I hope you had some time to stretch your legs and back and so on. But let's continue here in Trafo room with the agenda. Next up, we have Mari Rüütli and Ilja Dmitrovski from our longtime partner, Nortal. Mari is a QA specialist there, and Ilja is a senior QA specialist and test automation architect. Today, they will share their approach how to tackle complex multi-service world obstacles like end-to-end tests, for example, and what tools they use for that. So, Mari and Ilja, I hope you are ready.
Thank you for the introduction. And hi, everyone. It's nice that you have joined our presentation about how we do end tests in a multi-service world. We will try to give you an overview how have we approached the challenges that we are facing when we are doing test automation in a project which has many event-driven microservices and also has a large number of third-party external services. But before we dive in, let's introduce ourselves a little bit more. So I'm Ilja Dmitrovski, and I have been working in QA field for the past 9 years, mostly in private sector, testing media and aerospace applications, and also doing team leading activities. For the past 5 years, I have been involved in test automation, building different frameworks, helping teams and projects to find best solutions for their needs and their contexts. So I'm really into test automation myself, and I see this as a great potential in a QA field in general.
Yeah, hello, I am Mari Rüütli. I am actually celebrating my 10 years in testing in a few days. And I have mostly spent my time on testing various state-related governmental systems. I'd like to think that I do my little bit to make Estonia a better place to live at. So first, I would like to introduce you to our dear system under test. Our dear system under test is probably operating quite similar to many other Estonian state-related public sector systems. We have here a bunch of microservices, and as many other systems also do, we have also a grumpy old guy who is old, somewhat special, but very dear to us. And all these parts of our system need to interact with each other. One way to do that is by using asynchronous messaging. And for that, we have the so-called postal office, meaning the message broker. Asynchronous messages are used when we need to communicate that some sort of an event has happened to all the other services. And the other way to communicate is by using direct synchronous REST requests. This is mostly used when, for example, one microservice needs some specific data from the other. And also synchronous requests are used when the UI talks to the backend. So this means that basically everything that a user can do in the UI, for all that, we have a specific respective API endpoint. Our application is also part of the thing we might call the Estonian state ecosystem, because in Estonia it's literally prohibited by law for any of the governmental bodies to ask the same data from the citizen twice. So instead, all the different systems need to communicate and get data from each other. So to enable this, in Estonia, we have this thing called XD or X-Road. This is both a technological and organizational platform for the members to exchange data. So so that our application could talk to XD. Inside our application, most of the communication is done by REST, and in the form of JSON, but outside there is still good old SOAP in use, which means XML. So we have a special microservice that does most of the translations, and in order to get access to the XD, there is this mandatory security server that acts as a gateway. So as you can see here, we have microservices, messages, we have REST, we have JSON, we have SOAP, we have XML. This is like plenty for us to chew on.
Yes, exactly. And as most of you in testing and in test automation know, we face different kind of challenges each day. And I would even argue that these challenges that we are facing on our daily work are what makes this field so very interesting. But let's now dive into some of the challenges that we have been facing and also how we have tried to solve those challenges. Event-driven architecture, this poses some challenge regarding different timing uncertainties for us, because events happen in different times and we usually are not sure what is the specific time that something is about to happen. But in test automation, it's really good to have a deterministic outcome, even not only for the functionality itself, but also for the timings. So we have here implemented a polling system on our endpoints. So basically, the tests themselves try to figure out if the expected outcome is now done or not, based on the time that we have predefined before how long the polling should actually take place. We have no specific waits or thread sleeps for a single requests defined. Instead, we have this polling system implemented so that the one request can be sent multiple times to the specific service, and once the expected result is returned, we pass on and go on with the next step actually. This helps us to avoid somewhat well-known anti-pattern of having static thread sleeps or waits directly for a single step.
Yeah, the second challenge we find quite interesting is actually the quick development cycles. We have 2-week sprints, probably similar as many others do. And during that time, development is taking place on multiple microservices in parallel. So there are countless code merges to the stable branch. And this kind of development pace gives us the assignment to find out whether any of these changes impacted some of the business critical scenarios or not. So the tests have to be quick, and we really need stable feedback from them, because no one has time to waste on false positives from flaky tests. So in order to have these rather stable test runs, we have made this strategical decision that we use only the REST API endpoints, more specifically the same endpoints that the UI uses. Another thing regarding feedback time is to build the tests so that they could be run in parallel. This reduces the execution time like considerably. Once we enable test parallelization, the execution time dropped about 75% actually. And currently we have like around 300 steps, which are executed in less than 3 minutes. The stability of the tests is, of course, something that we are constantly working on because we need the confidence in our test scenarios. And to ensure the stability, we are reviewing always both the test code, the test scenarios, and we also test the tests. So how would you test a test? Well, basically similar to anything else. We are creating failing conditions and running the tests so to see if they can catch these artificially created issues and to check for the flakiness. We have the tests up and running in a continuous loop for some amount of time. The time depends on multiple variables, but mostly we consider the complexity of the test scenario. For example, we have had one test up and running for about a week before we were confident enough that now this test is good, not flaky, and can be merged.
Time and resources. These are the things that usually the time is not enough and the resource is not infinite. So we have to, considering this, basically we have to pick the right test that we want to do on our context and which kind of test suits our context best. So in our context, actually, we have picked end-to-end tests, which focus on full business critical scenarios. And we have additional twists in there as well. When we create those kind of scenarios, we try to think how can we flow through as many microservices as possible, because this just gives us like the extra layer of the coverage itself besides the business critical scenarios.
Yeah, and the next hardcore challenge is the data from external services, because we are part of the state ecosystem. Our system constantly needs to interact with others, but we cannot control the data, and the limitations of data can interfere with the actual test scenarios we can conduct. So we have implemented a mocking service. We have picked Wiremock for that. And this helps us both with the automated end-to-end tests, but also when a human being, maybe a QA, a developer, whoever needs to run some test scenarios, then mocking is something that is of assistance. So, and we have covered the main challenges. Let's look into what the testing framework actually looks like.
Yes, exactly. And here we'll try to talk a little bit about the building blocks of the test automation platform itself. So first, the core component in most automation platforms is the framework itself, in which we can manage the tests and test cases themselves. We have a general purpose and in-house built framework. This allows us to be quite flexible in regarding what kind of capabilities we need to use. And also, if we discover that there are some issues, then we can quite easily fix them ourselves, or just switch the used component or the library with the working one quite easily. The framework itself is written in Kotlin, and the test code itself is also written in Kotlin. The framework project is Gradle and Spring Boot, and as already mentioned, it contains different kind of libraries inside. And here, let's focus on some of the main and most relevant libraries that we have in there. First, we have Spring Boot included in there. This gives us actually a wide variety of different capabilities. First is the possibility to connect to different databases, to execute queries and get information back, and also update and inject data directly to the database. Then we have Docker management coming also from the Spring Boot, because it has nicely built-in Spring Boot capabilities, which allows us to create Docker images and push the Docker images to the Docker registries. In our context, we have multiple environments where the test needs to run. So we also need to have configuration management. So Spring Boot also allows us to quite easily and nicely have different configuration files and in general, just really nice configuration management built in right away. Then also the last point about Spring Boot is it allows us quite easily manage dependencies and dependency injections directly in the code already. The next component, which is also really important and the big one, is Cucumber. This is just to glue together the business side of the scenarios which are written in Gherkin to the actually implemented code that's written in Kotlin. Then we have JUnit. This is actually, I assume most of you know what JUnit is. This is a really big framework on its own, but we use just some of its capabilities just to enable different parallelizations, and how we exactly run the tests is managed through JUnit itself. Then we have AssertJ, which is creating rich set of assertions. And this is just to complement the different asserting capabilities that are coming from the next component, which is rest assured. And rest assured we are using for the web requests. And also, of course, it has some basic validation capabilities, which we are using, but with the previously mentioned component AssertJ, we are able to do much more complex set of assertions as well. Yeah, so these are the fundamental libraries of the framework itself, but of course there are many others available, which here I will not talk in detail, but because there are just too many of them. The next is test platform architecture. Our test platform architecture actually contains of quite a lot of different components, but there are two main ones, the test framework and the application under test itself. And then we have support tooling available as well. So here is one component which we call testlib. This is also implemented in-house, and this is for creating different preconditions. Then we have Wiremock. Mari will talk about this in more detail later on, but this is for creating stubs on demand. Then we have support tooling, which is Report Portal, and this is just for aggregating different test results. And also this is for to enable everyone to easily access the test results and also view some statistical information about it. Simplified tool across this diagram is looks something like this. So the test framework starts executing the tests, and it contacts the testlib, which then creates the precondition data in the database and sends the needed events to the message broker. Then the microservices access the message broker, pick up the messages, and then go to the database and check out the data. And after that, our precondition on the application side is basically completed. Now, the next step is that the test framework actually sends the information directly to Wiremock as well, so to create the needed stubs for executing the tests. Now, when all this is done, the tests are able to now start test scenarios directly against the application itself. And usually, in most scenarios at least, the microservices, one or another, needs to contact those third-party external services. And this is why we have Wiremock here. And then the application directly connects the Wiremock and gets the pre-made stubs from there. Once the tests are done, the report is visible in the report portal. And as we also send a lot of logging information there, it is really helpful for us to be able to debug issues when they arise. Parts of the CI. So we have two main parts to it. So first part is to execute or to build the test solution when the tests are stable enough. To build the test solution means that basically the solution is built and then packaged as a Docker image and then pushed to the Docker registry. This is actually really crucial because we don't want to have different environmental variables and environmental dependencies to interfere with our test solution. So it is nicely packaged in a Docker image. The second part of it is once the packaging is done, the microservice pipeline itself is executed. It has a job which is for running the tests. Now the tests are pulled from the Docker registry and executed. And these results are then, of course, published to the report portal itself. But here we really require that the tests run quickly because we don't want the pipeline to take very, very long time. We want to get the feedback rather quickly. And of course, the tests themselves have to be really stable. And that's why we have a stabilization phase for the tests as well.
So since we have mentioned Wiremock for like 1,000 times already, quick intro. As we said, our application needs to talk to the other state services all the time. So we decided that since we can't change the data at these systems, at these external systems, we substituted them with Wiremock. And Wiremock is a simulator for HTTP-based APIs. It can be run as a standalone process, so all we have to do is have it up and running somewhere, and we can turn to Wiremock instead of going to talk to the security server. The most important concept of Wiremock, we might say, is mapping. And mapping is pretty much telling Wiremock that, hey, if you have this kind of request, then please give us this kind of response. It can be written down in JSON, which is really nice because that is language agnostic, and people with not much development experience can handle this too. To get the mapping to Wiremock, there are, let's say, two options. You can just save them as static files at the same place where Wiremock is running, or you can use the administration API. So you can have REST requests to send the mapping to Wiremock. So if a test or some human being is doing any more specific case testing, then you can post your mapping, because we mostly have the static file mappings as the default layer of responses to always get some sort of happy path response from the external service. So if our application actually does the request, Wiremock checks all the mappings it has, whether they were written in those static files or sent by a REST request. And then if it finds a matching one, it sends back the response from that mapping. And if the testing is done, then the test or a QA can just pretty much delete the specific mapping from Wiremock. So have we learned something from all of this?
Let's see. So the first key takeaway: simplify and be open to taking risks. If you already have a solution in place, revisit it and try to analyze if it's possible to make it more simple. If it is really complex, then this makes much more sense. But even if you already have a simple solution, makes sense to revisit this topic once in a while. Going from more complex to less, you can, in certain ways, reduce some costs. You can even get some quicker execution times, and maybe you even can get rid of some of the infrastructure that you have been using so far. So try to think about it, try to analyze if it's possible to go simpler. Maybe there are some tooling out there that can help you do that as well. But be careful because this can also mean that you may lose some of the coverage that you already have. So really make an educated decision when going more simple.
Secondly, it seems that quicker tests equal pretty much happier everyone. If you look at developers, for example, they always need quick feedback so that they could have their work really streamlined. But this can help everyone who has to deal with a test in a way or another. So no one has time or really wants to wait for hours to get the test results. So in our case, having your tests run under 10 minutes is already quite nice, but having them run near or under 5 minutes can actually be considered like really good. And the execution time of tests can be reduced by using many different approaches, but we find that it's really important to keep this thing in mind from the very moment you start implementing your automation solution.
Explore tooling possibilities, and if you can't find the right tool for your needs, it may be an input for you to create one tool for yourself. So one important point here is that not everything can and has to be implemented in the test framework itself, because some of the tooling used separately can be really helpful for the other team members if they are not using your test automation framework. But this really needs to be thought through. And again, context here matters the most. If possible, try to find the tools that are suitable for you, which are already present. But if not, you can do them yourself or use your developer friend who can help you develop the tool you need.
Next thing, mocking, use it if you need it. Because having third parties can really restrict the things you can test. So it's ways to substitute them with maybe a mocking service. Of course, again, you need to be attentive that you might miss if something changes at the third party service. But this is a risk you need to consider, and perhaps you can even mitigate it with some aspects from contract testing.
System and life and world, these are the really, really complex places. So find a way that is suitable for you at the end of the day to figure out what meets your specific needs. And we really hope that some of you got at least a couple of ideas regarding end-to-end tests you might use. And maybe some of you thought that, hey, my current solution is way better than all this. And this is also an important thing to know. So we really wish you all luck in finding out what works for you.
Yeah.
Okay. Thanks for the experience. It seems like really well designed approach, and I hope that most of us or a lot of us learned how to sleep better at night, because we now know how to tackle those obstacles that the real life has to offer on a daily basis to us. I think there aren't any questions from workshop environment, But I was just curious, you mentioned a lot of frameworks and languages. Was this selection a straightforward path for you, or you tried initially some alternatives that didn't work out for some reason, or just didn't feel that convenient?
Well, actually, the selection itself was made before we already, but the selection idea and the base for that was quite easy. The framework itself was used already previously for other tests, and now the language selection itself was changed to Kotlin because it just to simplify the writing of the code in a great deal, basically. So previously, coming from Java to Kotlin was just a simplification measure, basically. And of course, regarding the components themselves, the components were already in this framework before, because this framework was somewhat extracted from the application, how the application itself was built up.
Yeah, but it has gone through like lots of simplifications, let's say.
Yes, a lot of refactoring and simplification has gone into making it a test framework.
Yeah.
Okay, great. So, but are there any plans for further refactoring, or are there any shortcomings that you would like to maybe present us next year?
Well, yes, we have actually a lot of different ideas how we want to proceed. One aspect that we have mapped out and is really important for us is to go and further simplify. This means, from the framework perspective, that we want to actually get rid of some of the libraries that we are using, because at some point of time they have showed us that we don't need them anymore, and some of the actions are now done already by support tooling, which can be used by everyone in the team quite easily. So just the main focus is to simplify and try to figure out what makes the framework even more usable.
Okay, great. I see that we have some questions coming in. And first one being that why report portal has been chosen? Are you using auto analyzer feature of report portal?
Currently, we are not using this feature, but it is definitely on our agenda to switch it on, actually. Yeah.
Okay.
Why we have chosen this is because, well, there are other similar tools available, of course, in the market, but we really wanted to try out and get the knowledge of how this actually works. Does it suit our needs in a proper way? And so far, it has proven to be really really like a cornerstone for us and really helpful.
Okay, great. So another question from the audience. You showed that you insert the test to database. Do you have separate databases for each test run, or you use same shared database?
We use one database per environment. So we have separate environments, and each environment has its own database. And it's not per test. Yeah.
Okay, great. Well, I think that's all of the questions at this point, and we can use the spare time for stretching our legs for some time. And I really enjoyed the talk, and there were several good points that would need to take with me as well. So thanks for that, and thanks for Nortal for supporting Nordic Testing Days for several years already. I'm seeing that there is some questions coming in. Maybe we can take one. Let's see. If you're okay, we can take one more. How do you argue for simplification when managers want to add features to the test system, and which arguments seem to carry the most weight? Yeah, it's basically you know, about the simplification.
Mm-hmm. Well, we can quite easily argue for the simplification, because simplification in large scale means that we have to put in less effort to write the tests and to eventually also maintain the tests themselves, and also to maintain the framework itself, if we go to the simplification route. So this is our main point, why we really want to go the simplification route. Of course, the systems themselves, which are under test, they get more complex each day, but we have to find this fine balance where we cannot go more simple anymore from our framework perspective, but where we are now at this moment, we know quite well that at least we can go more simple.
Okay, great, thanks. Thank you for the short answer. I guess we can take the fourth one as well, thanks to that. So what type of tests run in each service's pipeline? Unit integration, API, end-to-end?
Actually, today we were talking about end-to-end tests, but beside the end-to-end tests, we also have unit tests, of course, running there. We have integration tests that are also running in the pipeline, and we have not that much, but some UI tests made by Cypress as well. Yeah.
Okay, great. I think that's all for the questions. I really thank you for your presentation. We will share the slides afterwards. And this is a wrap up for Trafo Room today. Thank you for joining. You can switch now to parallel sessions. There will be one session before lunch still. And I kindly invite you to also visit the expo area where Nortal is giving out a top-notch Logitech StreamCam. So thank you for joining, and I hope you enjoy the rest of the event, and take care.